We now want to look at how to solve inequalities in one variable. And we can actually solve these using properties that are in fact very similar to the properties that you use to solve equations in one variable. We actually have about 6 properties here, and I've grouped them together 2 at a time, and we're going to find that a lot of them are very similar to the properties that we use to solve equations. Only differences might be those 2 that I wrote out in red. So let's take a look at these properties. The first one says that if A is greater than B, then A plus C is greater than B plus C. This is similar to the property of equality that said you can add anything you want to the 2 sides of an equation without changing the equation. Now note that I've used greater than in all of these statements, but could have easily used less than, greater than or equal to, or less than or equal to, and the properties would work the same way. The second property says that if A is greater than B, then A minus C is greater than B minus C. Again, just like the property of equality that said we could subtract anything we want from the 2 sides of an equation. If we were to look at a problem, say like x minus 5 being greater than 3, this first property says that I can add 5 to both sides, just like I would with an equation. The 5's will cancel, you'll get the x on the left, the greater than will stay greater than, and you'll get an 8 on the right hand side. We can also draw this answer. We can sketch this answer out on the number line. Of course, it's going to center around 8. We're going to use the open parenthesis to mean there was no equal to in the question. So the 8 itself isn't included. I will shade off to the right hand side, and there I have drawn my answer. In a similar fashion, I can subtract. If I had a W plus 11 being less than or equal to 5, I could subtract 11 from both sides. That would cancel. You get the W on the left. Because I did nothing but subtract, and it doesn't matter what you add or subtract, the sign will stay the same, so the less than or equal to will stay less than or equal to, and I'll get a negative 6 for my result. And just as easily, I can come down and graph. Now this time I had the or equal to in the original problem, so I will put the square box on to say that's included, and the shading would be to the left hand side to indicate less than. Alright, so the first 2 properties are working out the same way. The next 2 say that if A is greater than B and C is greater than 0, by this statement greater than 0, you should take that to mean that the C is a positive value. This property says that you can multiply both sides by C and the sign won't change. The next statement says that if A is greater than B and C is greater than 0, again saying C is a non-negative number, then you can divide both sides by C and the signs don't change. All right. Examples of this would be, say, 2x plus 3 being greater than or equal to 5. I can subtract from both sides and the sign doesn't change. I can divide both sides by a positive number, and again the sign didn't change. And once again I can draw my answer. Here is the 1 on the number line. I will use the square box because the or equal to was there, and the shading would occur out to the right hand side. And division works the same way. Right? Division works, and multiplication would work just as well. For example, if I had a 1/2 y plus 9 being less than 10, I could subtract the 9 from both sides, and I get a 1/2 y being less than 1. I can at this point multiply both sides by 2. 2 and the 1/2 cancel, and y would be less than 2. Again, to draw this, here's the 2, round parenthesis means don't include it because there was no equal to. And you would shade to the left-hand side for less than. So everything's been the same so far. Only thing that might be a little bit different is if you had a statement like 3 is greater than 2x plus 5, and you decided to put the 2x plus 5 on the left-hand side, and you decided to move the 3 to the right-hand side. In other words, just exchanging left-hand side and right-hand side. At that point, you would need to change the symbol so the orientation would be correct. At that point, you could subtract the 5 from both sides, and you have a 2x being a less than a negative 2. You could divide off the 2, and you would have x. The less than would stay less than because you did divide by a positive value, even though you got a negative result. That doesn't matter because you did divide by a positive, and that never changes the sign. And again, you can draw the solution by shading the number line, and that's what it would look like. Now let's look at these last two, see where the difference is. The last two say that if A is greater than B and C is less than 0, in other words, they are specifically talking about a negative value here. If you multiply or divide by that negative value, the sign has to turn around. And that's the main point in the last part of that property, is that multiplication or division by a negative value will in fact change the sign. So let's look at an example or two of this happening. Clear a little bit of space here, some older examples. And let's see how that works. Let's say we had a negative 4x minus 3 being greater than 5. I would first add 3 to both sides. I would get negative 4x being greater than 8. At this point, I would divide by the negative 4. And because I am dividing and the value is negative, the sign would turn around and go from a greater to a lesser. And again, we could draw this, but there's really not a lot of point to that. We can clearly see how that would work out. And again, let's try another example. Let's look at an example where we're going to have to multiply instead of divide. If I had a negative 3/5 x plus 8 being less than or equal to 10, I would first subtract off the 8, and you get negative 3/5 x being a less than or equal to 2. This time I'm going to multiply. I will multiply by negative 5/3. In other words, I'm using the reciprocal to cancel out the fraction. The 5's would cancel, the 3's would cancel, the negatives would cancel, and you would get the x. It would become greater than or equal to, and you get a negative 10/3 for your result. Again, remember, dividing or multiplying by a negative is what changes the sign and causes it to turn around. Now you can also run into a couple other type of situations. It is possible, like with your linear equations, to end up with either infinitely many or no solution at all. And the way that happens is similar to what you've seen before. For example, if we had a 2 times an x plus 3 being less than or equal to a 5x minus a 3x plus 8, we would start distributing and we'd get a 2x plus 6 being less than or equal to. Here, combining like terms, I get a 2x plus 8. When I subtract off the 6, of course at that point the sign does not change. I'll subtract off the 2x. The sign does not change because I did not multiply or divide by a negative. And what I'm left with right here is a true statement. The variable is gone. That's very important that you notice the variable is gone. The statement is true. That means your solution is all real numbers. All right, the other side of that coin, if I had something like a 4 times an x plus 1 being greater than x plus 5 plus 3x, I will get a 4x plus 4 being greater than, when I combine these two, I've got a 4x plus 5. Subtract off the 4, and I get a 4x greater than 4x plus 1. Subtract off the 4x, and I get a 0 greater than 1. Again, it's important to notice the variables have all disappeared. And this time you're left with a false statement. So you can reach the conclusion that this problem has no solution. So you have to watch out for those two special cases exactly the way you did when you were working with the linear equations.